The quantum leap! From room-sized computers to a chip that could change everything, our minds are about to be blown. We are witnessing the dawn of a new technological era. One where a supercomputer occupying half a kilometer and costing 5,000 crore is about to be rendered obsolete. This is the power of the quantum revolution, led by innovations like Google's new Willow quantum chip. The staggering promise of quantum power. Today's fastest classical supercomputers, like perform calculations at an unimaginable scale, quintillions per second. Yet, Google's quantum chip promises calculations that are a nonillion times faster. That's a 1, followed by 30 zeros. To put this in perspective, a problem that would take our most powerful classical supercomputer 500 trillion times the current age of the universe to solve could be cracked by this quantum chip in just 5 minutes. This isn't just incremental progress. It's a paradigm shift. Quantum computing is the wild card that could reshape the entire landscape of artificial intelligence, scientific discovery, and human existence itself. A glimpse into a quantum-powered future. With such computational power, science fiction could become reality. We could unravel the universe's deepest secrets through impossibly complex simulations. Calculate the potential for alien life across billions of planets. Design revolutionary technologies like light-speed travel or conceptualize stable wormholes. Model and eradicate all human diseases, potentially extending lifespans to 150 to 200 years. Even explore uploading consciousness, achieving a form of digital immortality. The historical journey. How did we get here? To appreciate this quantum leap, we must look back. The story of computation began not with electronics, but with mechanics. The Antikythera mechanism, a 2,000-year-old Greek device found in a shipwreck, is considered the oldest computer. It used intricate bronze gears to calculate astronomical positions, codifying the laws of the universe into mechanical movement just as modern computers use algorithms. Centuries later, pioneers like Blaise, Pascal, and Gottfried Leibniz built mechanical calculators. However, the need for faster, error-free calculations in navigation and engineering led Charles Babbage to design the difference engine and the visionary analytical engine, the first concept of a programmable computer. His collaborator, Ada Lovelace, wrote the world's first algorithm for it. The electronic revolution, from bulbs to silicon. The shift from mechanical to electronic computing was the first great leap. Ironically, it began with a light bulb. In 1883, Thomas Edison, while experimenting, discovered the Edison effect. He could control electron flow inside a vacuum tube. This principle became the foundation of vacuum tubes, the building blocks of early electronic computers like ENIAC. These room-sized beasts were powerful but incredibly inefficient, prone to overheating, and required constant maintenance as bulbs blew out. The breakthrough came in 1947 with the invention of the transistor at Bell Labs. This tiny semiconductor, first germanium, then silicon, could control electron flow like a vacuum tube but was smaller, faster, and more reliable. This gave birth to the Silicon Age and the tech hub we know as Silicon Valley. Integration was the next step. Jack Kilby's invention of the integrated circuit IC in 1958 allowed thousands of transistors to be packed onto a single chip, making computers smaller and cheaper. The final revolution in classical computing was the microprocessor. In 1971, Intel's 4004 CPU placed an entire computer's central processing unit on a fingernail-sized chip. This led to Moore's law, the observation that processing power doubled roughly every 2 years as transistors shrank from 10,000 nanometers in 1971 to just 3 nanometers today, the end of an era and the quantum dawn. However, we are hitting physical limits. Transistors are now so small that electrons become unpredictable, leading to errors from heat and quantum interference. Moore's law is slowing down. This is where quantum computing emerges as the next fundamental force. Classical computers use bits, 0 or 1. Quantum computers use qubits, which can be 0, 1, or both simultaneously, a state called superposition. This, along with other quantum phenomena, like entanglement, allows them to process a staggering number of possibilities at once. As IBM executive Robert Souter notes, simulating a single caffeine molecule precisely would require a classical computer to process an amount of information equal to 10% of all the atoms on Earth. For a quantum computer, this is a natural task. The race and the challenge. Today, giants like Google, Microsoft, Amazon, IBM, and Intel are in a fierce race to build practical quantum computers. They look different: Google's cryogenic chambers, IonQ's trapped ions, Xanadu's photonic chips, because they use various technologies to create and control qubits. The major hurdle preventing quantum computers from becoming household items is error correction. Qubits are incredibly fragile, easily disturbed by their environment. Before we can unlock the futuristic applications, scientists must solve this tricky problem of maintaining stable qubits long enough for complex calculations. Google's Willow chip represents a significant milestone in this journey, demonstrating a leap in computational supremacy and bringing the quantum future closer than ever before. The game is about to change, and the next chapter in human technological evolution is being written now. If this story resonated with you, please subscribe, like, share, and comment below. Your thoughts encourage the creation of more stories like this. Thank you for listening. Until next time.